So welcome to the second video of step 1, where we discuss about the basic building block of Fourier transform. We just want to visualize what is going on in the Fourier transform. Okay, that's it. There's no need to panic. And I think in the last video I shouldn't have discussed computational stuff because that might scare you. It's fine if you don't understand them. It's not important to understand them at this point. You will eventually understand later. And I mistakenly uh, cut off the video too early, and so in the last part I couldn't write it down, but I didn't reshoot it because it's just a small part and I had said it like 2 times, so I just wanted to clarify about that. There was nothing more than that over there, and you don't have to panic for mentioning convolutional stuff. It's fine if you don't understand that. Let's just progress slowly. It's fine. So in this video, where we can see there's a mechanism, a factory mechanism. We can consider it a factory mechanism. Okay, so f of t just contains the value of the function. Okay, so as we had said before, that no function is actually continuous in real life. So if we think f of t has a finite number of values, it has 500 values. Okay, if f of t has 500 values, it's gonna give all of the values in the Fourier transform block, this magic block, right, this black box. So, and we're gonna give frequencies in. So if you notice here, the difference between each frequency is df. I can set df. Okay, it's not a problem, I can set df, but there is one problem, and that is the maximum we can go up to. Okay, uh, maximum we can go up to is size of FST in df. Okay, this is the maximum we can go up to. Can go about that. For now, just remember this. Don't worry about this because we're gonna see mathematical examples later where we are gonna clarify this. Okay, so these frequencies will go in one by one like a for loop. I believe you know what a for loop is. So will go in one by one, and every time it's gonna take the f of t, the whole matrix of value, 500 values, is gonna take that, and it's gonna return an amplitude value and a phase value for each frequencies. So the amplitude against the frequency won't be 0, but it will be close to 0. There will be some values, and it will only peak when the frequency over here matches a frequency in this signal FT. That is the only time when it will peak, right? So yeah, that's it for this video. Just keep in mind that this f of t will always be given as an input over here. So f of t is always present, and the iteration goes on in the frequency. It iterates from 0 to this value, size of this f of t into d of f, the amount of spacing we are taking for frequency. Okay, so yeah, this iterates and goes in one by one, and for each frequency we get an amplitude value and a phase value. After plotting the amplitude against the frequency, we will get the amplitude spectrum, and after plotting the phase against the frequency, we're gonna get the phase spectrum. This is the most basic idea of a Fourier transform. That's it for this video. I'm not giving any assignments or homework over here. In the next video, I will show you the continuous Fourier transform and how it works, why it works. Just give a very basic overview. see you in the next video.